Okay, so when we're discussing ratios, ratios can always be looked at as just another way to write a fraction, okay? So in this case, with a ratio, we have a numerator and a denominator just kind of flipped over on its side here. So in this example here, we have 1 to 2. So if we were writing that in a fraction, it would just be 1 over 2. Same thing here, 3 to 4 would just be 3 over 4. Just like fractions, we can always reduce these into the lowest terms, so please make sure that you do that on your assignments. Also, really important concept here that we will cover in later chapters, quantities must always be in like units. So they give the example here, we can't compare inches to feet in a ratio, okay? We would first have to change this foot into inches before we could compare the two. So let's take a look at a couple examples here. So once again, ratio is just another way to write a fraction. So 4 to 5 would just be 4 over 5. Same thing here, 2 to 6 would just be 2 over 6. Now we could further reduce that by dividing by 2. That would give us 1/3. So in your slides here, expressing ratios as proportions. Now, ratio and proportion is going to be a topic that we cover very soon in these next coming weeks, and it's going to stick with us once again throughout the entire book. So this is a very important concept as a ratio here. So let's just get an example. So here I have, we see two ratios being compared to each other, okay? So how I would read this as 8 to 5 is equal to 16 to x. So anytime you see double colon signs, that is just another way to write equal. So if I was writing this as a fraction, I have 8 to 5, which would just be 8 over 5. These two colons means equal to, and then I have 16 to x, or 16 over x. Now, if you have not seen two fractions being compared to each other, where you have to solve for x before, please pay attention very carefully to this process. So to solve for x, we're going to use what we call cross multiplication. So we're going to cross diagonally, and we're going to take 5 times 16. So 5 times 16, enter that into your calculator. That gives us 80. Now we're going to keep the equal sign here, and we're going to do the same thing this way. So 8 times x would be 8x here. Now, the point of this equation is to solve for x. We want to get x by itself. So here I have 8 times x. So we want to do the opposite of multiplication, which is division. So if I divide off 8 here, that is going to cancel off my 8. But whatever I do to this side of the equation, I have to do to this side as well. So I'm going to divide this by 8. Now we have 80 over 8, which, remember, anytime you see a fraction, same thing as a division problem. So 80 divided by 8 gives us 10. And then I'm just left with x on the other side here. So we just solved for x. So our ratio would then be 8 to 5 is equal to 16 to 10. We just solved for that unknown variable of x. So let's look at another example here. Now keep in mind, your x could be anywhere in this equation. So here we have it at the first number. So this is saying x to 25 is equal to 60 to 250. So let's first start by rewriting this in fraction form. So x to 25 is the same thing as x over 25. My double colons indicate an equal sign, and I have 60 over 250. Now I want to get x by itself, so I'm going to cross multiply. So 25 times 60, we can use our calculator here. 25 times 60 gives me 1500. Keep my equal sign and cross multiply this way. So I have 250 times x. Now this is a multiplication problem here, so I want to do the opposite, which would be division, because I want to get x by itself. So divide by 250 here, divide by 250 on this side. So we're going to take 1500 divided by 250, and that leaves us with 6.